Hello and welcome to this video. I've recently found this micrometer in the scrap metal bin at work, and it still works as far as I can tell. There are a few parts from it missing, and in this video we will be making these parts to repair it and get it to its former glory. The main thing that is missing from it is the stop, the clamping part on the top, which allows you to clamp it so it doesn't move when you want to read the dimension of it. But everything else looks absolutely perfect and fine. I'm not sure why they threw it out. It also appears to be still pretty accurate. As you can see, this is a bearing outer race, and they usually are pretty accurate. It's one of the most accurate parts in this size that I have, and it looks to be pretty spot on. Doesn't look like it's like completely off. And here I have other micrometer, and that clamping part is what we're going to make. And to see how they did this here, they just have a screw, a thread, and they when turning you clamp it on the cylinder. And the problem is I do not have a cylinder or a threadbare set in the micrometer, so I will have to make something that goes in the hole that's in the body of the micrometer. I will make a cylinder that goes in from the top with a crossbore for the spindle, and then a thread on the top where I can use it to clamp down the spindle. For this project I will be making a lot of small parts that have to be accurate, centered, so I will be using my collet chuck bushing in my spindle. This is an adapter bushing from Mark IV spindle to W20 collet chuck, and I often use it when I have to machine small parts that have to be quite accurate, or just for convenience, because for grabbing small parts it's more convenient than the 3-jaw chuck, because you have a bigger surface area that's clamping on it, so you're not destroying the surface. Here I'm turning down the first part. This will be a fixture for machining the main cylinder that will go into the micrometer bore. I will use this, or I need this fixture because I don't have a boring head, and so I will have to machine the accurate bore for the spindle of the micrometer on the lathe. On the milling machine I am now centering the spindle on the part, so I have the center line of the fixture. Then I will take it out and lay it flat, because I will have to make a crossbore in this part. These are some really nice 90 degrees centering drills, full carbide. I got them from work. They were not good enough anymore for the parts that they machine. Now we can drill a smaller hole and then enlarge it. This is not very optimal with the drill, with the big drill, because it's like the cuts that start just on two sides, and that's can get it offset. But I went after the drill, I went in with the reamer, and this really centered it up. Now I'm gonna start to make the cylinder for the spindle of the micrometer. I'm making it out of brass, because it looks nice and it's fairly nice to machine. Here I am making the diameter to fit in the bore of the fixture with a nice press fit, and after a bit of filing, this actually gives me a really nice surface finish on this machine, and I can quite easily control it. And I only had to take off very little material, so that's why I used the files here. Make some nice chamfers on it, and then we can cut it off. I'm sorry for the very shaky camera footage. I mounted the camera on the machine. I really should not do that, and I won't in the future. Now I can press it in with some light taps. And now the part is perfectly positioned, because the outside diameter of the fixture has the exact diameter that it needs. So when the cylinder that gets pressed into the micrometer sits, or the shoulder of it is on the outside diameter, and I put it in the lathe and drill the hole, that the center line is exactly where it should be for the spindle of the micrometer. You saw that it was pretty accurate, and with a bit of tapping I was able to get about 1/100th of a millimeter runout, which is pretty good for this machine, and it's accurate enough. Man, I just love these new drills that I got. They are incredible, and they were actually pretty cheap, but now we can bore out the hole, or the bore. For this I'm very sorry, but I did not record it properly. That's why you can't really see it that well. I basically just bored out the hole, both in the aluminum part and the brass part, until the spindle of the micrometer fits in nicely. You can see that the surface finish came out looking pretty nice. Now we can, with very light taps, hit the brass part out of the aluminum part again. This actually worked better than I expected it, but I'm not gonna complain. This bore is now perfectly positioned and the right size for using it in the micrometer. Now I just turn down the top of it, and because I don't need it to be that tall, I just had it that tall so I could machine it better. Putting on a nice chamfer and then using this incredible boring bar. I basically just use the boring bar because the inserts that I have for the boring bar give me extremely nice surface finishes in all materials, so that's why I, for the last pass, always use the boring bar. Now I can use the thread cutting guide. If you're interested in this, I am linking it on the top right of the video right now. There's a video series about this and how I made it. It allows you to cut inside and outside threads very easily and very accurately on the lathe. Here you can see that really nice surface finish that the boring bar left and the nice thread. Now we can press it in into the micrometer. You can see it's a nice fit in there. And after some fiddling around to get everything aligned, I was able to put in the spindle through the bore, and everything fits and everything moves freely when it should. And next we are gonna make the clamping screw knob with a nice knurl around the outside that I will need for clamping the micrometer spindle. For this I'm using a piece of stainless steel so it doesn't rust, and also the boring bar, because the insert to machine it I'm using the boring bar because the inserts are way nicer than the ones I have on my other tool holder. I am trying to go for 3mm so I can then cut the M3 thread on the outside. Obviously, we can't forget the chamfers. Now again with the thread cutting guide and this fixture, we're mounting the thread cutting die for the M3 thread, and also M4 and M5 and 6 I think. This can then also just be inserted into the thread cutting guide with this very convenient 4-jaw chuck. And this just works very nicely. I absolutely love how good this or how easy it makes it to cut any threads with. Doesn't matter if we with a tap or a die. Look at those chips. I really enjoy cutting an outside thread because you can always really nicely see how the beautiful thread gets cut. Now for the knurling part, I am machining the outside diameter to an exact dimension that fits with the pitch of the knurling tool. So I calculate the knurling tool has a pitch of 1mm, so every tooth is 1mm away from the next tooth, and then you have to make on your part, the outside diameter has to fit with 1mm, the circumference has to fit with 1mm, and then you can just machine the knurling without any troubles. I also used my normal tool to machine the backside chamfer. And here you can see how flexible my top slide is. When cutting off, it often flexes multiple millimeters probably, or it looks like that at least. You can see that beautiful finish. And now this is the finished product, finished project. And if you enjoyed this video, I hope you learned something new, a new technique. And with that, thank you for watching, and until the next video.